Lesson 5.3 is solving trigonometric equations. So we're going to solve them either using some algebraic techniques or some basic identities. So the first thing we want to look at is isolating the trig expression. So really this trig expression is just like you would with algebraic. So we need to move it over to the other side. So we have 4 sine x minus 2 sine x. So that's 2 sine x equals the square root of 2. And then just keep solving it, just like you would algebraically, divide by 2. And then sine of x equals the square root of 2 over 2. So if we look on the interval from 0 to 2 pi, so from 0 to 2 pi, we're looking for everywhere that the sine of x is equal to the square root of 2 over 2. And so if you look at your unit circle and go around it and you want the positive sign, you're going to find that it's at pi over 4. And then also at 3 pi over 4. Now, this is on that interval, and so if you wanted all of them, you would just say pi over 4 plus 2 pi n, and then 3 pi over 4 plus 2 pi n, because you want every one as it's going around the circle, and n is an element of integers. So pay attention to whether it's asking for all of them or just within a certain domain. Next technique is just to take the square root of both sides, which we still have to isolate our trig function, trig right here. So I need to add 4. I get 3 tangent square root of x equals 1. Divide by 3. So tangent square root of x equals 1/3. And then take the square root. Now be careful when you take the square root. The square root sign wasn't on there to begin with. So that means we have to put a plus or minus. So square root of 1 is 1. And that's over the square root of 3. Don't like that. Plus or minus. That's a plus or minus. Square root of 3 over 3. Which, in all honesty, when you're looking around the unit circle, this one's a little easier to look at because you're looking for 1/2. And square root of 3 over 2. And remember, this is y. And this is x. So the first place that it is pi over 6. And then the next place is going to be at 5 pi over 6. And the next place is going to be 7 pi over 6. And the next place is going to be 11 pi over 6. So just looking right there, did you guys notice that the denominators were all the same? Notice I needed them all because it was plus or minus. So basically you need them all. And then, of course, if we're going to do this, we need to go ahead and add 2 pi into each. But one thing I noticed is that a couple of them are pi away from each other. So I could just do 2 of them and say pi over 6 plus pi n, because that one's 1 pi away. And then these two are 1 pi away. So 5 pi over 6 plus pi n. Of course, n is an element of integers. Next technique is by factoring. So the first way we're going to look at factoring is by factoring out the GCF. So I'm going to move this over to this side because I notice they both have a sign in it. So this is 2 sine x cosine x minus 3 sine x equals 0. And this time notice it says on the interval, so I'm not going to go around anywhere else. And so I'm going to factor out the GCF sign, and I have 2 cosine x minus 3 equals 0. Set both of my factors equal to 0 and solve. So where is sine x equal to 0? And then go ahead and solving this. 2 cosine x minus 3 equals 0. Cosine of x is equal to 3/2. So sine of x, it's 0 at 0. It's also 0 at pi. And so I'm done with the sine. The cosine of x is never equal to 3/2, so that one's just out. So this is my answer. And notice I don't go to 2 pi because this is an open interval, so don't include the 2 pi. I don't need to include it. All right, another technique It's still factoring, but this time you're just going to put it into group. So 2 times the negative 1 is a negative 2. Factors of negative 2 that when you subtract give you a positive 1. So that's going to be a 2 minus 1. So factoring this is 2 sine of x. Oops. And erase that. That's the minus right there. And you're kind of like, how do you know? When the number is in the front here, you have a couple options. Since it's an equal sign, you could have gone through and just changed the signs on all of them. And then you know you need a positive one. Right here, a negative one in the middle. Sorry, not a positive one. Or else, you know that because it's the other way, everything's going to kind of be opposite. So then the other group is sine of x, because it's a 1 sine plus 1. And you can check it. This will be a negative sign, and then this will be a positive 2, which gives you a positive 1. And then you solve those. So sine of x equals, from this one, move the 1 over and divide by the 2. And then sine x equals negative 1. So where is sine equal to half? It's equal at pi over 6. It's also equal to half at 5 pi over 6. And of course I don't have to keep going around because of the restrictions on the domain. And then the sine of x, where it's equal to negative 1, is 3 pi over 2. Next one says find all the solutions, so we need to add the 2 pi into it. The last technique is by rewriting using a single trig function. So look at this first one, and I see a sine and cosine squared. So I'm going to think, okay, let's move that cosine squared over to the other side. So actually, yeah, go ahead and keep it negative. Sorry, I was contemplating something. I can't factor it because they're not like terms. I can't pull out a GCF, so the next option is to change. And so I'm going to change this cosine of x. Cosine of x is equal to 1 minus sine of x. So 1 minus sine squared, of x, plus sine of x plus 1 equals 0. Distribute this negative 1 in. Negative 1 plus sine squared of x plus sine of x plus 1 equals 0. The 1's cancel out, and I'm left with sine squared of x plus sine of x. It's a plus. Equals 0. Now I can factor out a GCF. So sine of x, sine x plus 1. So where is sine equal to 0, and where is sine equal to negative 1? Oh yeah, it stayed together. So I look around the unit circle. Sine is equal to 0 at 0. It's also equal to 0 at pi. And I want all the solutions. So I can just say this is going to be pi n, where n is an element of integers, because it's pi away continuously. And then where is sine equal to negative 1? That's 3 pi over 2. And that's the only one, so plus 2 pi n. Let's erase that. That's a little messy. 2 pi n. All right, the next one, secant and tangent. So thinking through this one, this is a technique that you probably don't think to use quite off the top of your head. I'm going to go ahead and square both sides. And the reason I'm going to do it is because I know that on my Pythagorean identities I have a secant squared plus a tangent squared. And so, or actually a tangent squared plus 1 equals a secant squared, so that'll help me some. So I have a secant squared x, and don't forget to FOIL this. It's 2 secant x plus 1 equals tangent squared x. So now I can take and change this tangent squared to a secant squared. So secant squared x plus 2 secant x plus 1 equals, and tangent squared is equal to secant squared x minus 1. So then the secant squareds cancel out. I have 2 secant x plus 1 equals negative 1. Move that over. So 2 secant x plus 2 equals 0. And then I'm just going to go ahead and solve this. So secant x, 2 secant x, let's do that, equals negative 2. Secant x equals negative 1. Now remember, secant is the reciprocal of cosine. The 1, so all we're looking for is where cosine is equal to negative 1 on the unit circle, and cosine is equal to negative 1 at pi. So it's pi plus 2 pi n.